These are notes 8.8 on solving quadratics by square roots. So we're going to show you one more method today for solving quadratic equations. And before we get into the meat of the lesson, I want you to turn to the back, and down at the bottom there's a little space on the back side. So I just drew a line down there. I'm going to show you a couple things. So the first thing I want to remind you of is this. On my little t-charts that I have here, I'm going to say that the top is x. That's my value of x. And on the bottom, we're going to figure out what is it if x was squared. So if I take the number 1 and I square it, 1 times 1 is 1. 2 times 2, 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And so I could go to infinity squaring numbers like that. Now let's look at the bottom side. On the bottom side, okay, so on the bottom side, if we have x and x squared, if I take negative 1 times negative 1, I still get positive 1. And negative 2 times negative 2 is still positive 4. Negative 3 squared, 9. Negative 4 squared, 16. And negative 5 squared, 25. We've talked about this many times in class, that whether you're squaring a negative or a positive, you always end up with a positive. Now, where this is going to come in handy for this lesson is when you have a question like this. Let's say we have x squared equals 25, and we're trying to solve for x. To undo an x squared, we're going to take the square root, and so I have to do it to both sides. And so the square root of x squared is x, and the square root of 25, as we can see over here in my little cheat charts, is either plus or minus 5. So both of those are legit answers for the square root of 25. So you need to remember that as we go through this lesson. Now, the second thing I wanted to mention was thinking back to our factoring days when we had factors like x plus 4 times x plus 4. We could see that the x plus 4 was getting multiplied times itself, and so we said that would be the same as x plus 4 squared. So how does that come into handy? Well, let's say I have x plus 4 squared, and I say it equals 36. And so we want to undo the square, so I'm going to take the square root, and so now I've solved this, and the square root of x plus 4 squared is just x plus 4. What times itself gives me x plus 4 squared? X plus 4. You can see it right up here. We did it once, we did it twice, right? So x plus 4 is equal to plus or minus 6. Okay, so we're going to have problems that look like that. The final thing I wanted to mention is this. What happens if you have a square root and there's a negative number under there? Well, 81 positive is a perfect square, but negative 81 is a different story. And if you were to do second and then square root key and put in negative 81, you would receive an error message on your calculator. Because we can see over here in our initial little discussion that whether we multiply positives or negatives, we always end up with a positive when we square it. So there's no way you could multiply a number times itself and end up with a negative. So in a situation like that, we have no solutions because you cannot have a negative sign under the radical. Okay? So now let's get to the meat of the lesson. Let's jump over there to page 1. So I'm going to skip number 1 for now. Let's jump into these easy problems down here, starting with number 2. So we want to find the square root and solve using square roots. And in this lesson, our goal is to get the x squared isolated by itself on one side of the equation. So this starting problem is really nice because it's isolated already. So we're going to take the square root of both sides, and the square root of x squared is x, and our solution is going to be plus or minus 15. And if we were to take x squared and we subtracted 225 and set it equal to 0 and then graphed this equation, you would see on your coordinate plane a quadratic that goes like this, and your two solutions are going to be positive 15 and negative 15, just like that. Okay, so, but we solved it using square roots. Let's look at number 3. Number 3 has 4x squared minus 25. So we want to get x squared by itself. Let's add 25 to both sides. So I get 4x squared equals 25. Now still looking to get x squared by itself, so I'm going to divide each side by 4. Well, 25 doesn't divide nicely by 4, but what it does do is provides me with a fraction where there's a perfect square in the numerator and the denominator. So we still want to solve for x, so we're going to take the square root of both sides, and so our final answer is going to be x is equal to plus or minus 5 over 2, the fraction, or 2.5. Because the square root of 25 is 5, the square root of 4 is 2. Okay, let's try number 4. On number 4, we're going to subtract 100 on both sides, and so I get x squared equals negative 100. So how do we solve for x? We take the square root, and we find that we have a negative under the radical sign, and so, as we discussed already, that's going to be no real solutions. Let's try number 5. Well, why don't you try it by yourself? Hit pause and do it, okay, and see how you do. And so you subtract 5 from both sides, you get a 0, and the square root of 0 is 0. And so this particular quadratic, if we were to graph it, if you set the equation equal to 0, you would have the parent function, y equals x squared, and there's only going to be one solution with the vertex hitting 0. Now, let's go to number 6. And this one we want to do it in steps. Remember, our goal is always to get x by itself, so the easiest thing on this to do is to start with dividing each side by 4. So let's get the 4 off that parentheses there, and when I do that, I get x plus 2 squared and that's going to equal 81. Now at this point, we want to undo the square, so let's take the square root of both sides. So we get x plus 2 equals, and what's the square root of 81 when we're solving like this? Plus or minus 9. Now at this point, we have two little problems that we need to solve. We have x plus 2 equals positive 9, and we have x plus 2 equals negative 9. So let's go ahead and solve both of these. For the first one, I'm going to subtract 2 on both sides, and so I get x equals 7. On the other side, I'm going to subtract 2 on both sides, and I get x equals negative 11. So there's our two solutions, which we could write like this, x, I'm going to put this negative 1 first, like that. Okay? Let's try. Why don't you try number 7 without me? Okay? Give it a shot. Hit pause and do it. So your solution should be x is 0 and or 20. Okay? And you can see my work there. I divided by 2. Then I took the square root and was left with x minus 10 equals plus or minus 10. Then I made my two little problems. X minus 10 is positive 10, x minus 10 is negative 10, and solved them out. Okay, good. Let's move on to numbers 8 and 9. Okay, on numbers 8 and 9 it says solve the equations and round your answer to the nearest thousandths. So it sounds to me like they're not going to come out nice and beautiful even. So let's use our strategy of getting our x by itself on one side. So I'm going to start by adding 2x squared to both sides. So we get 2x squared equals 80. Now I'm going to divide each side by 2. So I get x squared equals 40. At this point, we need to take the square root of both sides, and we get x equals plus or minus the square root of 40, which is quite an ugly number. And so you pop that baby into your calculator, second square root 40, and you find out that it's approximately equal to 6.3245. So if we're rounding to the nearest thousandth, which is this digit, we want to look past it and decide, are we going to round up or down? And so we're going to round up because it's a 5. So our final answer is x equals plus or minus 6.325. I should use squigglies. It's approximately equal to that. If you wanted to double check your work on that, put this equation into your calculator and graph it. Put y1 equals 0, put y2 this equation, graph, and then find your intersection points and make sure this is how they're coming out. Okay, let's do number 9. Why don't you try it without me? Give it a shot and see what you can do. So on this one, I ended up with x being approximately equal to 5.477. So again, you can look at my work. I subtracted 90, then divided by -3, and we got x squared equals 30. Took the square root, so x is equal to plus or minus the square root of 30. And this is the square root of 30 from my calculator, and we want to look past the third digit. And so we're going to leave it the same. We're not going to round up because it's below 5. So there's our answer, plus or minus 5.477. Okay, so at this point, let's jump back up and look at the word problem up at the top. So it says, for scene in a movie, a sack of money is dropped from the roof of a skyscraper. The height of the sack above the ground is given by this function. Where t is time in seconds, how long will it take for the sack to reach the ground? So if it's asking us about the time, we're just trying to solve for t. So let's do this using square roots. So in order to do this, I'm going to add 16t squared to both sides of my equation, and we get 16t squared equals 576. Now I'm going to divide 16 on both sides, and I get t squared equals 36. And now we're going to take the square root of both sides, and we get t is equal to, that's a perfect square, plus or minus 6. Now let's think about it. The question is asking us about a function of time, and do we ever have negative time? And that would be no. So we're going to ignore the negative answer and say that t is 6 seconds. That's the amount of seconds it takes for the sack to drop. And there we go. So if you were to graph that function, what you would be doing is finding where it hits where y is 0, because that's where the ground is. It's at 0 feet. Remember, h was the height and t was the time in seconds. So what we found was the number of seconds it took to hit the ground. Okay, now let's pop down to the bottom. It's a little bit, maybe a little more challenging problem. Okay, a zookeeper is buying fencing to enclose a pen at the zoo. The pen is an isosceles right triangle, so we can see the right triangle, and if it's an isosceles right triangle, the two legs are congruent. There is already a fence on the side that borders a path. Okay, so here's the path. So this side of the triangle right here already has a fence, so I'm going to mark it off. The area of the pen is going to be 4,500 square feet. The zookeeper can buy fences in whole feet only. Important information. How many feet of fencing should he buy? So the goal here would be to find out how long these two sides are of the triangle. And since we don't know, we're going to use x, and since they're both the same, we can use x on both sides. Now, what we need to do to solve this is think about how to get the area of a triangle. So the area formula for a triangle is base times height divided by 2. So let's plug in what we know. We already know that the area is 4,500. And the base and the height of our triangle are both x. So we have x times x divided by 2. So we have 4,500 equals x squared over 2. Now the simplest and easiest way to get rid of a fraction is to multiply by the denominator. So if I do it on that side, I have to do it on both. So I get 9,000, and these twos cancel out, is equal to x squared. Now how do we solve for x at this point? We take the square root. Okay, so we take the square root and we find out that x is approximately equal to 94.868, plus or minus, right? But since this is a length, we are going to ignore the negative solution and only keep the positive. Now this doesn't answer the question because we need to find out how many feet he needs to buy, and he can only buy in whole feet. So x represents only one side, and so we have to do this times 2. So if we multiply 94.868 times 2, I get 189.74 approximately. But we want to get whole feet only, so we're going to have to round up to make sure he has enough. So the zookeeper needs to buy 190 feet of fencing. Okay, good. Now let's go to the problems on the back. Okay, the height of a skydiver jumping out of an airplane is given by this function. How long will it take the skydiver to reach the ground? This is very similar to the one about the sack of money. So we're going to be seeing how long does it take this skydiver to hit ground zero. So we're looking for the amount of time. Okay, I think you could do this yourself. Why don't you give it a shot? Hit pause and try it, and then you can look at my answers in a minute. Okay, so my answer is t is approximately equal to 14.1 seconds. And you can see my work here. First of all, we set our quadratic equal to 0 because we want to find when he hits the ground. That's the height would be 0. Add 16t squared. Then to get the t squared isolated, I divided each side by 16. And that left me with this. T squared equals 200. Take the square root, and you get plus or minus approximately 14.14. But since we're talking about time, we ignore the negative answer and round to the nearest tenth, it said right here. So that's 14.1 seconds. Okay, let's try number 12. A city is planning a circular duck pond for a new park. Okay, as soon as I hear the word circular, there we go, we'll draw a circle. The depth of the pond will be 4 feet. So I'm going to kind of come down here and put that. And the volume is 20,000 feet cubed. Find the radius of the pond. So we're trying to find the radius and to the nearest tenth. And they're so nice, they gave us the formula for the volume of a cylinder, which is what this pond would be. So Let's write our formula down. V equals pi r squared times the height, and plug in what we know. Well, we know the volume's 20,000, and we're multiplying times pi. You have a pi button on your calculator, so let's just leave that. We don't know what r squared is, but we do know the height is 4. So I'm going to do this in steps. I'm going to divide each side by 4. And so 20,000 divided by 4 is, of course, 5,000 equals pi r squared. Now at this point you can divide using your pi button, 5,000 divided by pi, and we're already going to start getting some yucky decimals, and I rounded it to the hundredths to begin with, and then we can round at the end again. So I got 1591.55 is equal to r squared. So now we want to take the square root of both sides, and I get r is approximately equal to plus or minus, and we have 39.89, and of course we're going to ignore the negative option because the size of a pond cannot be negative. And then it said round to the nearest tenth, so we look at the 8 and we go past, and so we're going to say r, the radius of the pond, is approximately 39.9 feet. And there we go. One more and we're done. Well, Beyonce, she wants to display her collection of Grammys on top of her bookcase shown below. The collection covers an area of 400 square inches. What should be equal for the top of the bookcase to have the correct area? So if they're all going on tops, we're saying that this right here has an area of 400 square inches, and we want to figure out what B needs to be, which would be this width right here. I didn't do that very well. Let's use a different color. We're trying to find this, which is B, okay? So let's think about, how do you find the area of a rectangle? Well, the area is equal to length times width. And so the length of this bookcase is 5B, and the width is B. And we know that the area is 400. So let's do this in steps. 400 equals 5B squared. Let's divide by 5 on both sides, and we get 80 equals B squared. Take the square root, and we get B is approximately equal to 8.944 plus or minus. Now we have measuring distance, so we're going to ignore the negative solution, and we're going to round to the nearest tenth. So here's the tenths place, and we're going to leave it as is. We're not going to round up. So B is equal to, or approximately equal to, 8.9 inches for the depth of her shelf. Okay? Bada bing, bada boom, you're done. I hope you understood all that, and we'll see you in class and do some more practice problems there. Okay? See you. Bye.